Okay, so now we're going to start talking about single and double replacement reactions. But first, single replacement. So in a single replacement reaction, one element replaces a similar element in a compound. So many single replacement reactions take place in aqueous solutions, which that is very important. Aqueous solutions. So single replacement reactions can be represented by the following general equations. So A plus BX will produce AX plus B, or Y plus BX will produce BY plus X, where A, B, X, and Y are elements, and AX, BX, and BY are compounds. So when using or configuring single replacement reactions, we need to use an activity series. And the ability of an element to react is referred to as the element's activity. The more readily an element reacts with other substances, the greater its activity is. So an activity series is a list of elements organized according to the ease with which the elements undergo certain chemical reactions. So for metals, greater activity means a greater ease of loss of electrons to form positive ions. And for nonmetals, greater activity means a greater ease of gain of electrons to form negative ions. So we can use an activity series for metals and an activity series for halogens. And that activity series for halogens is just a periodic table. So the best way to get good at this is to practice. So a lot of times here, you're just going to be given a half reaction. You're going to have to create your products and determine if a reaction will occur. So to start us off, say we're going to have our products, our reactants are Al plus Pb parenthesis NO3 parenthesis 2. All right, so we want to figure out our products and if products conform. So what we need to do is we need to look at the first metal that is in a compound here. And the first metal that is involved in a compound is Pb. So I want you to take your activity series and I will locate where Pb is and star it or highlight it, wherever you need to do. And locate where Pb is, okay? So the element that wants to replace Pb is aluminum. And look where aluminum is on your activity series. So, very important, if your second element, we'll say second metal, and we'll say element because we're going to talk about halogens with this as well. Remember, element meaning halogen or metal is above your first element. And when I mean first element, I mean the element that starts in the compound, comma, a reaction will occur. Very important. Okay, so now, if my second element is below my first, and remember my first is the element in the compound, a reaction, remember RxN is reaction, will not occur. Right? Why would we try to make a reaction when the other element that we're replacing with is weaker than the first? There's no logic in doing that. So a reaction will not occur. So on a quiz, assessment, project, activity, if a reaction doesn't occur, all you're going to write is no reaction and move on. Now, very important, we need to make sure that both of the metals are on the activity series for a reaction to occur. So I'll rewrite this. Getting sloppy. All right, so we have Al plus Pb parenthesis NO3 parenthesis 2. So we already said a reaction will occur. So now we look. We're going to have aluminum, Al parenthesis NO3 parenthesis 3 plus Pb. Pb will be all by itself. Now, the last thing we need to do here, we need to balance our chemical equation. So to do that, we're going to put a 2 in front of the Al, 3 in front of the lead 2 nitrate, 3 in front of the Pb, and a 2 in front of the Al. All right. So now another example here. Say we had Na plus H2O will produce something. So now, which we know hydrogen's on a metal, but it's on the activity series, so our first element that's in a compound is hydrogen. So that's number 1. Number 2 is sodium. And I look at my activity series, and sodium is above hydrogen, so a reaction will occur. So we'll have Na, OH, plus H2. If I balance this, I'll put a 2, 2, 2, and then a 1. This is a displacement of hydrogen in water by a metal. Another example. Say we had Fe plus H2O will produce, and I'll tell you now a reaction will occur. And for the transition metals, I would have to tell you the charge if they're by themselves to start, and I will tell you now this is, you know what, we're not going to do this one. Let's erase this one. We'll go to another example here. All right, we'll do 3 more examples here. So, say we had Fe plus CuCl2. And I will tell you that iron will be +3 if a reaction will occur. And CuCl2, we know that will be copper 2. Okay, so we look here. So we look at copper on our activity series, and we locate iron. So iron is above copper, so a reaction will occur. So it will be FeCl3 plus Cu. All right, so now we go to balance this. We see we have, the only difference here we have is we have 2 chlorines on the left, 3 on the right. So we want to find a number to go multiply into those. So to get an even number, so we'll put a 3 here and a 2 here. We'll see what happens. So now we have 1 Fe, 3 Cu, and 6 Cl. On the product side, we have 2 Fe, 6 Cl, and 1 Cu. So, do a little work here. We have 2 Fe on the right, so that means we need 2 on the left. So we'll put a coefficient of 2 there. Cl's are good. We have 3 Cus on the reactant side, so that means we need 3 on the product side. So our coefficients would read 2, 3, 2, 3. All right, so now we look. Say we had Ca plus NaOH. So we look at sodium on our activity series, and then we look at calcium. And calcium is above sodium, so a reaction will occur. So Ca parenthesis OH parenthesis 2 plus Na. So what do we need to do? We need to put a 2 in front of this NaOH and a 2 in front of the Na. So we'd have coefficients of 1, 2, 1, 2. Now last one, we'll do one with halogens. All right, so say we had one that said, say we had Cl2 plus NaBr. So our first halogen that's in a compound is bromine, so we locate bromine on the periodic table. And we see the halogen that wants to take the place of bromine, which is chlorine, and chlorine is above bromine, so it means a reaction will take place. So we have NaCl plus Br2. Now to balance our equation, we'll put a 2 in front of the NaCl and a 2 in front of NaBr. So we'll have a 1, 2, 2, 1 coefficients. Also, let's do one where it actually doesn't work out. So say we have Cl2 plus NaF. So we locate fluorine on our periodic table, and our element that wants to replace fluorine is chlorine, but chlorine is below fluorine, so that means no reaction. Okay, so now single replacement reactions are done. Let's go on to double replacement reactions. So, in a double replacement reaction, the ions of 2 compounds exchange places in aqueous solution to form 2 new compounds. And one of the compounds formed is usually a precipitate, which we know is a solid. An insoluble gas, means it's not dissolved in water, that bubbles out of solution, or a molecular compound, which is usually water. and the other compound is often soluble and remains dissolved in water. All right, so it says a double replacement reaction is represented by the following general equation. AX plus BY will produce AY plus BX. And AX, B, and Y in the reactants represent ions. And AY and BX represent ionic or molecular compounds. So the cation here in the first element is going to go with the anion from the second compound. And the cation from the second compound is going to go with the anion from the first compound. So our example, a precipitate of barium carbonate is formed when aqueous solutions of barium chloride react with potassium carbonate. Write a balanced chemical equation for the double replacement reaction. So it tells us barium carbonate is formed. So that's a product. So our reactants are BaCl2 plus K2CO3 aqueous. So we look here. So this Ba is going to go with CO3 because it tells us barium carbonate, BaCO3, which is our precipitate, which is a solid, plus KCl, which is aqueous. Let's cut off a little bit. All right, now to balance the equation. So I think all we need to do here is put a 2 in front of the KCl and we're good. So our coefficients are 1, 1, 1, 2. And that concludes our video on double and single replacement reactions.